So we are most worried about the electric vehicle is, let's say I have charged my vehicle fully, how much kilometer I can go. And let me tell you the truth about it. It is extremely difficult to calculate how much kilometer you can go because it depends upon the driving behavior of an individual. And just to give you an analytical perspective about it, we already calculated what is the energy consumed in 1 kilometer, and that is completely depend upon the torque of the motor. And let's say you are driving your vehicle, let's say from 0 to 20 kmph in 4 seconds. That's what your behavior of driving is. But for me, I go, let's say 0 to 20 kmph in 10 seconds, very smooth. So in your case, the torque of the motor is going to be extremely high. But for my case, the torque of the motor is going to be less than in your case. And hence I am going to consume less energy from the battery, but however you are going to consume much higher energy from the battery. Then for you the range will be less, and for me the range will be very high. So that is how it's become more complex in calculating exact range of the vehicle. But the engineers or researchers has come up with a method or idea where they can on an average predict what would be the range of the vehicle. So what they did, they put the sensor in the vehicle, or for let's say 100 users or let's say 500 users, and they started collecting the data. And just they collected two data. What is that? The speed of the vehicle and the time. And when they got the data, they performed the statistical calculations and they come up with what I call speed versus time. And they told us ki this is the average user driving pattern is there, and that pattern is known as a drive cycle. So here on the screen you see under the seat name fun with drive cycle. So this is the typical driving behavior of the users that you can see. Let's start from t is equal to 0 to certain time. So this driving cycle actually extracted for the IC engine. And what happens in the IC engine when we are waiting at the signal, that time our engine is on and we are consuming the fuel. But however, this will be not the case for electric vehicle. If it is, it's not moving, then it's not consuming any energy. But for sake of discussion, let's discuss this. So right now the engine is on but vehicle is not moving. Then after, what happens, it went, let's say 0 to almost 22 or 22 kmph in 4 to 5 seconds, and then it velocity they come down and then again accelerated, then again decelerated and again accelerated, decelerated, went with the constant speed and then accelerated and then decelerated and come to the 0. So that is how the typical driving behavior they came to know about it. And if I calculate the range on this driving pattern, then we are almost have some indication about it that this much kilometer I can go, and hence I am going to use this drive cycle to calculate the range of the vehicle that we are going to build. So this drive cycle is known as Indian drive cycle for four-wheel. I got it from the ARAI website, which I have already given the link here. And if you go to the page number 55, you will able to get this drive cycle. And also I have given another link here, which you click and you will get many drive cycle from many countries. So you are free to go and explore these two links. But I have converted this graph into the table here, and then I draw this curve using this table, and I got the same curve here. But I'm not going to use this much extensive a point for our discussions. I just simplified it and I extracted some useful data point and I put it here. And then when I draw the curve between time and speed, I got this curve, which is a simplified version of it, and I don't have any idling period in this curve. But you are free to calculate the range using this entire data point with the method that I'm going to discuss now.